This is the pre-lab video for the capacitors lab, and so I'll try and make this brief because I know you have some LabVIEW pre-lab videos to be watching as well. So the capacitor we're going to be studying in this experiment is made up between this upper plate mounted on this actuator and this lower plate which is sitting on the scale. The upper plate, well, this device here is a linear actuator and it has a piston which it can extend and retract, and that's controlled by the computer. And so we can vary the plate spacing of this capacitor. This capacitor is sitting on a digital scale which we've seen before, and the weight on the digital scale we can relate to the force that's being exerted on these plates of the capacitor. We have set below this lower plate of this capacitor some dielectric material. In the first part of the experiment, this dielectric material is meant just for a spacer and some extra weight ballast for the scale. And so in the first part of the experiment, the dielectric is below the lower plate, but it's not really involved in the experiment in any sense. And in the second part of the experiment, when we want to study this dielectric, we place the dielectric above the lower plate as such. And then it would be when we're studying the effects of the dielectric, that's what we'll do. So how does this capacitor work? How do things move? It gets moved by this linear actuator. How do we end up controlling that? Well, we have some software on the computer which sends a signal to this what's called a sensor DAC. It's an analog to digital to analog converter, and it sends a control voltage to this device telling it how to move. And we have our DC power supply which gives it its DC voltage, so it has power to move when it needs to. In addition, the voltage that we need to set on this capacitor is very high, so it's a high voltage. We'll be setting on the order of 3 kilovolts voltage to this capacitor. And so doing that is a high voltage power supply which is located in this gray box. And the high voltage power supply is also controlled, gets its base power from the DC power supply and gets a control voltage also from the DC power supply. And so that all happens inside of this box. But the point is that this high voltage comes out on the red wire and gets fed to the plus and minus high voltage get out on this red wire and black wire and get fed to the upper and lower plate of the capacitor for you to study. So in the first part of the experiment, you'll be collecting data manually. You'll be using a LabVIEW, pre-written LabVIEW program to control the high voltage and to control the position of the actuator. So you'll have fun doing that, I suppose. And then in the second half of the lab, you'll spend some time writing your own program to automatically collect data over a range of positions for the top plate. So you'll write a program that in the end you'll just run, and this thing will take a step, take a reading, take a step, take a reading, and just keep doing this and collecting data automatically. Well, that's the hope anyway. Well, that should be enough to get you started, and good luck.